We are now coming to section 5 of chapter 1, that's about limits. Of course, when we are talking about limits, that is mand or ghaya you have studied from high school. It's an easy subject. We are searching for limits of functions, of course. Again, we are dealing with functions, how to find their limits. What is the meaning of limits? When we are talking about limits, when we say that limit of f of x as x is approaching to c, that means we are checking the behavior of that function near that value c. Okay, for example, if you have got f of x that's equal to 3x plus 2, if it is required from you to find f of 2, or let me say f of 4, okay, what does that mean? That means I'm putting 4 except from limits, okay, I'm talking about functions now. That means I'm putting that 4 into the x here, okay, so that will be 3 multiplied to 4 plus 2. That's equal to what? That's equal to 14, simply. I simply input this one into there. I didn't care about the behavior of the function. How will it behave if I approach to that 4 from the left side and from the right side? I didn't care if I have got numbers less than 4 or more than 4. So what did I care about? I just cared about that value. To input it instead of the x gives me something valuable. I mean an evaluation, a solution for that function. But when we are saying find the limit of that function, for example, again, if I have got f of x that's equal to 3x plus 2, I'm saying find limit of that function, okay, 3x plus 2 as x is approaching to 4. Look, here I'm saying find f of 4, here I'm saying find limit of that function as x is approaching to 4. What's the difference between this and that? Of course, for polynomials it doesn't make a difference because still you will get the same result, but there are other examples that you will be familiar with later and you will see the difference between the limit and functions, inputting values. Here, when I'm saying find the limit of that function as x is approaching to 4, that means I'm approaching to 4 from both of the sides. I will input values to that x that are less than 4, for example 3.8, 3.9, 3.999. I will input those values that are less than 4, okay, approaching to 4. And I will also input values that are greater than 4, for example 4.01, 4.0001, 4.1. I will include those numbers into that function. I will input those numbers that are around 4 into that function. For example, if 4 is here, I will include here, for example, 3.9, here 3.8, and so on, okay. Here from the right side, I'm inputting what? 4.01. Here I have got 4.00, 4.1, not 001, and so on. Okay, so we are approaching 4. And when we are inputting those approaches into that function, we will see the function is behaving in a way. Sometimes it gives me something, a solution, sometimes it gives me nothing. The function will be undefined. Okay, so that is the behavior of the function near 4, and that is exactly the value of the function exactly at number 4. So this one in general will give me what? Limit of f of x as x is approaching to c will give me a value, will give me a solution for the function that I have got, and will tell me how will it behave near that number c. Of course, when we are talking about definitions, it would be a little bit complicated. You will not understand, but when we are coming to examples, it would be much more easier for you. The first example that is given in here, calculators are used here, but later on you will not need calculators. You will learn methods for finding limits of functions. Here, the first example, it says use a table to estimate the limit. It doesn't say find the value of the limit, it says estimate the limit. So we have got limit of x approaching to 1, root of x minus 1 over x minus 1. Okay, if you look at that limit, it says find that value of function as x is approaching to 1. Can I put 1 directly into here? For example, if it is required from you to find f of 1 for the function f of x that's equal to root of x minus 1 over x minus 1. Can I find that value? No. Why? Because when I'm inputting 1 into that function, it is what? Undefined. Why is it undefined? Because 1 minus 1 gives me 0. Up there is also 0. 0 over 0 is something undefined. It's an indeterminate form. So we cannot solve that function directly. We cannot put 1 directly into that function. So what will we do? We will check the behavior of that function near 1. I have got 1 here. Okay, I'm putting 1 here. I'll give values to that function from left and right. Let me do it. Of course, this one is given to you in the course material. It's written for you. Okay, so that is easy, and you will not also need that table onwards, because we are using methods for finding limits of functions. Okay, if I give values that are less than 1, I will start, that's of course I'm giving values to x. I'll start with 0.999 and 0.49. Okay, look, I'm giving values less than 1, okay, and giving values more than 1 but very near to 1. Okay, so that would be 1.0001, 1.0001, and so on. So we are approaching to 1, but I'm not inputting that value directly into here. If I put this number into there, I will get 0.530 and of course you're using calculators. If I put this one into here, square root of 0.999 minus 1 over 0.999 minus 1, you're using a calculator and you will get that result. Okay, that is the value of f of x. And for this one, I will get 0.50013. If I input that number from the right side, okay, that one is called the right side of number 1. Look, we are having 1 here. We are approaching from left and right. 1, we cannot find any value because it will make something undefined. If I put that number into the function that we have got, I will get 0.12349 or even 59. And this one I'll get 0.4999. So if you look at this function, what values will it given to me when I'm approaching 1 from left side and right side? Look, that is if you compare those two, that's nearly 0.5. okay, so the more you approach 1 from the left side, the value is approaching to 0.5. okay, and the more I approach to 1 from the right side, 0.49999 is equal to what? It's nearly 0.5 again. Okay, so nearly the function is behaving, that means approaching to 0.5 when I'm approaching from left and right. That's called the behavior of the function near 1, but not at 1 itself, because at 1 itself it's giving me something undefined. Since we checked from the left, it's approaching to 0.5, and approaching from the right gives me 0.5, so the result of that limit is 0.5. Although it's not defined at 1, but the function behaves well near 1 from the right side and the left side, and it is approaching to 0.5, so the result is 0.5. Of course, as I told you, you will not need this table for later, because we will have methods for solving that kind of questions. Sorry. We have got some algebraic properties of limits. Let me write it for you. Algebraic properties of limits. The first property that we have got, of course, when we are talking about the properties and working on the functions that we have got, first we should consider that limit of f of x approaching to c exists, okay, and limit of g of x. So we have got two functions, f of x and g of x. Both of their limits are approaching the same number. The numbers are not different. These ones both exist. That means I can find their values, sorry, as we did for that one. The first algebraic property that we have got is the summation of limits. If I have got limit of f of x plus g of x, the limit is distributed over those two functions, and I can say that that's equal to limit of f of x alone plus limit of g of x alone. So the limit is distributed over them. What does that mean if I'm coming to an example? If I have got limit of x as this approaching to 1 for 3x minus x squared, consider this one is f of x, okay, and that one is g of x. Of course, if you have got more, it is still distributive, okay. If you have got, for example, h of x and those ones, it is still holding, okay. I can give that limit to this one, so that will be limit of 3 of x minus limit of x squared, as x is approaching to 1 for both of them. Of course, when we are talking about summation of limits, the subtraction is also true. Here I have got subtraction, so it is also distributed over subtraction. So you limit of 3 of x, you're calculating it alone, limit of x squared, you're calculating it alone, and you will get the result. The second property that we have got is that limit of constant multiple function k f of x, okay, as x is approaching to c, that's equal to what? K limit of f of x. What does that mean? If we illustrate this one with an example, we have got, for example, limit of 3x as x is approaching to 1. I'm giving simple examples just for making you understand the properties, nothing more, okay. So that 3 is considered as a constant multiplied to a function, okay. A constant is multiplied to a function. So how can I deal with this one? I can take this 3 out of the limit, okay. 3 limit of x as x is approaching to 1. Finding that limit will give, and multiplying it by 3 will give me the result, okay. So it's just a concept. Later on, when we are coming to the examples, it will be much more easier for you, because we will practice lots of examples. Okay, the third example, the third property is that if you have got multiplication of two functions, limit of f of x multiplied to g of x, as x is approaching to the same number, again limit is distributed over multiplication, so that will give me limit of f of x as x is approaching to c multiplied to limit of g of x as x is approaching to c. If you look at these ones, please, x is approaching the same number, that x is not changing. So if this one is approaching to 1, that would be 1 and 1. If it is approaching to -3, that would be -3, -3, okay. That limits will not change. Okay, let's give an example. If x is approaching to 2, for example, x minus 1 multiplied to x squared plus 1. If you consider this one as f and consider this one as g, you can separate them easily, okay. Of course, finding that limit, separating them may be much more easier than solving it together. So that will be limit of x as this approaching to 2 of x minus 1 multiplied to limit of x squared plus 1. So I separated this one with that one with the limit for both of them. So the limit is not just for this side or that side, it's for this one and that one multiplied together. Okay, the fourth one, we have got limit of quotient, okay. So I've got f of x over g of x, that's equal to what? I can again distribute the limit for both of them, so that would be limit of f of x over limit of g of x. When we are doing this one, of course, we have got a condition here. Limit of g of x must not equal to 0. Why it must not equal to 0? Because it's in the denominator. If it is equal to 0, it will give me something undefined. Let's come to a simple example again. For example, x is approaching to minus 2. Okay, x minus 1 over x squared plus 1. Since it's a quotient function, I know that limit is distributive over quotient function. Okay, so that will be limit of x minus 1 as x is approaching to minus 2 of x minus 1 over limit of x squared plus 1 over as x is approaching to negative 2. So the limit is for up and down. The last property that we have got is the power. Limit of x as this approaching to c of f of x to the power of p is equal to what? That limit can go inside underneath the power, or let me say that would be better. So that will be limit of f of x as x is approaching to c to the power of p. Giving a simple example again. For example, if I have got x to the power of 5, how can I calculate this one in general? How can I deal with this one also? I can say that that's x approaching to 3, x all to the power of 5. So I can give that power to all of them. It still gives me the same result, will make no difference. Okay, let's come to the limit of two linear functions. These are the properties. Of course, we are using those properties in general while solving the limits. So we have got limits of two linear functions. Very simple ones we are starting with. The first one is a limit of k. That means if I have got a constant, any constant, and that x is approaching anything, it will give me the same constant. And I have got limit of x as x is approaching to c will give me c. That one is called constant function. That one is called identity function x. So if you have got x is approaching to any number, positive, negative, 0, rational, irrational, when I have got a constant here, I will get the same constant out. The result of that limit without hesitation is equal to k. And if I have got limit of x as x is approaching to that c, whatever that c here, that will come out. Okay, because I'm directly inputting that c into that x and will give me the required result. For example, if I have got limit of 3x approaching to 0. 3 is what? It is a constant. I don't care whatever this one is approaching to. The result is again 3. Okay? If I have got limit of minus 3, x approaching to 1, that's equal to what? Minus 3 is a constant. I don't care whatever this one is approaching to. The result is again minus 3. If I have got limit of 0 as x is approaching to 10, okay, what is that result? Since 0 is a constant, so limit approaching to anything is equal to 0. If I have got limit of root of 2 as x is approaching to 1, this root of 2 is a constant, okay, it's that k, so x is approaching to anything will give me the result that's equal to root 2. Okay, so when I have got a constant, the result is again the constant whatever that x is approaching to. Let's come to the identity function. If I have got limit of x as x is approaching to say negative 2, okay, so the result is negative 2. Okay, as I told you, that c comes out because when I put that negative 2 instead of x, gives me the result negative 2. Limit of x as x is approaching to 0. What is the result? Putting 0 into here, I will get 0. So whatever that number is with the limit, I will get this one out. This is for the identity function. This one is the constant function. Limit of x as x is approaching to root of 2. Okay, the number that I have got here is root of 2. So the result is root of 2. Limit of x as this approaching to let's say 1 over 3. Okay, so the result is 1 over 3. That's the basics of limits. 19, page 20. Let's move to the first example that's given in the book, in the course material. We have got example. Before moving to the example, I thought that it would be better for you if I explain this property and then move to the examples. It would be much more easier for you to calculate the examples that are given above that one. Okay, so what do we have here? We have got limits of polynomials and rationals. Previously, what did we have? We had limits of a constant. The limit of a constant is always that constant itself. Limit of an identity function is always that c that's approaching to it. Now we are coming to a limit of polynomials. In general, it says if you have got p of x and q of x are two polynomials, okay, are polynomials. I will write it shortly. Okay, how can I calculate limits? I'll always say that limit of x as this approaching to c of p of x, that's equal to p of c, and limit of x approaching to c for p of x over q of x is equal to p of c over q of c. Of course, q of c, sorry, that's c, must not equal to 0. What does that mean? That means if I am given a polynomial, polynomial is zoradadar. If I'm given a polynomial and it is required from you to find the limit of that polynomial as x is approaching to a number, I'll put that number directly into the polynomial that I have got. Okay, it's not making a problem. You know that polynomials are continuous everywhere. If you remember from high school, we have got no problem with polynomials. Since we have got no problem at all, so we can directly input that c into here and will give me the result for the limit. And of course, if I have got a rational function is a polynomial over polynomial. You've studied this one in college algebra. If x is approaching to c, if c is not making a problem in the denominator, that means it's not equal to 0. So I will directly input that c into the polynomial up there, and the polynomial down there will give me the result. Let's move to the examples that were given previously. Example 1.5.2. It says find limit of x as this approaching to -1 of 3x to the power of 3 minus 4x plus 8. If you look at this one, that is a polynomial. Polynomial is not making a problem for you anywhere on the real number. So if I put -1 directly into here, what will I get? It's like I'm finding f of -1. Okay, so that one is equal to 3 multiplied to -1 to the power of 3 minus 4 multiplied to -1 plus 8. Sorry, why did I do like that? Because if I input -1 into here, it gives me no problem, it makes no problem. So putting this one into there will be the same thing if I would check the behavior of that function near -1, I mean, from the left side and from the right side. Okay, it would give me the same result if I approach from the both sides. But since it is a polynomial, it is behaving the same way as f of -1, so I'm directly inputting that -1 into the function that I have got. So that result gives me, that would be -3. This negative goes with that negative, makes it +4, and that result would equal to 9. Okay, because that one together is 12 minus 3 is equal to 9. So it is easy. Of course, you can solve this one another way. You can use the properties of limits, distribute that limit over this and this and that. So that would be limit of x as this approaching to -1 for 3x squared, 3x to the power of 3 minus a limit of 4x plus limit of 8. You can separate the terms like it was given in here, but you do not need to do that. It is easy to go straight forward to the solution. We have got another example. It says find 1.5.3. It says find the limit of, find limit of x approaching to 1 for 3x to the power of 3 minus 8 over x minus 2. If you look at that limit, okay, what do you see? We see a rational function. Is that one making a problem here? If I put 1 above there in the numerator, will it make a problem for me? No, it will give me a result, so there is no problem with that. If I put 1 into here, denominator, 1 minus 2, is it a problem maker? No, again, it is giving me a value, so there is no problem if I would say that I can directly find this, okay, f of 1, or I can say that I'm writing p of 1 over q of 1, considering that case. Okay, it's a polynomial over another polynomial, so I'm directly inputting that number into there because it's not making a problem for me. So that would be 3 multiplied to 1 to the power of 3 minus 8 over 1 minus 2. That would give me the result as 3 minus 8 over minus 1. Okay, 3 minus 8 is equal to what? Is equal to 5. Minus 5, of course, with a negative down there is equal to 5. So that is the result. Or you can say that using the properties of polynomials, you can say that I will distribute that limit for this one and that one, solve them each separately since it's not making any problem for me, so that would give me the result. Okay, that's about polynomials and rational functions and how to deal with them when we have got no problem with the denominator. Okay. Now we are coming to the cases where that limits, when we are approaching those numbers, are problem makers. They are either making a problem in the numerator and denominator together, or they are just making a problem in the denominator. First, we are having an example. Of course, there are methods for solving these kinds of questions. We've got example 155. It's required from us to find the limit of x as it is approaching to 1 of x squared minus 1 over x squared minus 3x plus 2. Let's solve that one. We said if you have got a rational function and if we put 1 in the numerator and denominator, if it didn't make a problem for us, we will directly solve it, evaluate it, find the solution for that. Let's see if it is right for that example. If I put 1 into here, it will be 1 squared minus 1 over 1 squared minus 3 multiplied to 1 plus 2. If you look at this one, numerator gives me 0 and denominator 1 plus 2 is equal to 3 minus 3 is equal to 0. I get the case 0 over 0. 0 over 0 is something undefined. It needs to be solved. In general, when we are solving limits, and if you get 0 over 0, in general, that means it is solvable. How is solvable? That means we can remove that one from the domain of the function because that one is in the domain, but it is a problem maker, so I can remove that one from the domain of the function and still solve the problem that I have got. Why? Because it's not required from you to find f of 1. We cannot find f of 1 putting 1 directly into here, but we can check the behavior of that function near 1. How will it behave if I approach to 1 from left and right? So how can we solve this one? I will come to factorize it. Whenever I get 0 over 0, what will I do? I will factorize it. Factorize numerator and denominator. So that will equal to limit of x as is approaching to 1 of x squared minus 1 becomes x minus 1, x plus 1, all over what? X, this one changed into 2 brackets, x here, x there. For the 2, I will get 2 and 1. Since I have got negative 3 here, so I will have negative 2, negative 1. Why? because when I'm multiplying those two together, I will get positive 2. When I add them, I'll get negative 3. Now, if you look at both numerator and denominator, what do you see common? Look, we solved it. We put 1 into here. We got 0 over 0. In general, when we get 0 over 0, we have to factorize numerator and denominator if we could. Now we factorize it, and we're searching for the common terms. What is common between numerator and denominator? X minus 1 and x minus 1 are common. So what remains here? Here remains limit of x as this approaching to 1 of x plus 1 over x minus 2. Now if I'm inputting this one into both numerator and denominator, will it make a problem for me? Let's see. If I put 1 into there, that will be 1 plus 1 over 1 minus 2. 1 plus 1 is 2, 1 minus 2 is minus 1, that's equal to minus 2. It gave me the result. So when I got the 0 over 0 form, I could solve the problem. But when is that solution true? When x is not equal to 1. What does that mean, x is not equal to 1? That means we have removed that 1 from the domain of the function. Look, we factorized it and we removed that part. Removing that part means what? That means I have removed 1 from the domain of the function. Then I could solve the limit that was given to us. So that result of the limit is true when x is not equal to 1, or we can say that when we have removed 1, that one that's given here, from the domain of the function. Here we have got another example. The example is limit of x as this approaching to 3, x squared minus 9 over minus 4x plus x squared plus 3. Again, if you evaluate this one, that would be 3 squared, if I'm putting this one into there, minus 9 over minus 4 multiplied to 3 plus 3 squared plus 3. If you look at this one, that would be 9 minus 9, it will be 0, and that one is minus 12. 9 plus 3 is 12, so that will also give me 0. Again, we said if you have got 0 over 0, we can think of factorization. Okay, what does factorization do? We are factorizing both numerator and denominator to see if we can solve the limit that we have got. So if we directly input the 3 into the function that we have got, we cannot get the result. So we are using the method of factorization to see if it can be solved. If we want to factorize numerator, I can write this one as x minus 3, x plus 3, okay? How about this one? This one is changing into 2 brackets, x here, x there, okay? Because you can rearrange this one as what? As x squared minus 4x plus 3 if you want to rearrange it and see it nicer. Okay, we will write it like that. For getting the 3, I'm writing 3 and 1 here for multiplication. It should be both negative. Why? Because negative multiplied to negative gives me plus 3, and when I add them, I'll get negative 4. Now, if you look at both numerator and denominator, what do we have in common? We have got x minus 3 in common. So what is remaining from the limit that we have got after the factorization? Limit of x plus 3 over x minus 1 as x is approaching to 3. Now we have done the factorization. Let's see the result. If I put 3 into here, will it make a problem for me still? That would be 3 plus 3 over 3 minus 1. 3 plus 3 is equal to 6. 3 minus 1 is equal to 2. 6 over 2, that is equal to 3. So the result of that limit is equal to 3 whenever x is not equal to 3. What does that mean? That means we have removed 3 from the domain of the function. Okay, removed 3. Let me write it here. 3 is removed from the domain of the function. Okay, that x is not equal to 3, it's not related with this one. That's the result of the limit after solving it with factorization. Okay, but that result is true whenever x is not equal to 3. Why? Because if x is equal to 3, if we are not doing the approaching for the 3, we will not get that result over there. We are coming to limits involving infinity and reciprocal powers. Okay, limits involving infinity. If a is a constant, if a and k are constant, that means numbers with k greater than 0, that means that k is a positive numbers, then limit of x as this approaching to infinity of a over x to the power of k is equal to 0. And also we can write it both together, but here it is separated. X is approaching to negative infinity of a over x to the power of k is equal to 0. Okay, so what do we have? We have got a constant over x to the power of k. That constant doesn't make a difference if it is positive or negative. The same thing is true for this one. Okay, for that a. If x is approaching to infinity or negative infinity, the result is 0. For example, if I have got limit of 1 over x as x is approaching to infinity. Okay, 1 is the a, x to the power of 1 here, x is a positive number and x is approaching to infinity. So the result of this one is equal to 0. Again, if I have got limit of x approaching to negative infinity of 1 over x, okay, look, the same function, but here x is approaching to infinity, here is approaching to negative infinity, the result is equal to 0. If I have got limit of x as this approaching to infinity of 3 over x to the power of 5, 3 is the constant here, 5 is the k here, k is greater than 0, x is approaching to infinity, so that is equal to 0. The same result is true when x is approaching to negative infinity for the same function. Okay, so whenever you see a constant over x to the power of a positive number, okay, if x is approaching infinity or negative infinity, the result is 0. X approaching to infinity or negative infinity, for example 1 over 2 all over x to the power of let's say 10, that's equal to 0. Okay, so whenever you see that one, for example, again, let me give you another example also, x approaching to infinity or negative infinity. Look, I'm saying if it is infinity it's true, negative infinity is also true. Okay, that doesn't mean every time it comes for like infinity or negative infinity. I may give you as positive infinity or negative infinity. Okay, how about this one? 3 over 2x to the power of 5. What does that equal to? 3 is a constant, 3 over 2. Okay, it's representing the a, and x to the power of 5. I care about that. X to the power of 5, it's in the denominator, the power is positive, and since x is approaching to infinity or negative infinity, that will give me 0.